Hi, everybody. Welcome to this last assignments and content for physical science for the fall of 2021. So I'm going to go briefly on these 2 points. Let me prepare the screen first. Let me share it. So this is the last assignments for this week. I'm doing the recording actually before Thanksgiving break. So I'm going to touch upon a little bit of the stuff that we have before that. We have the review, which is due immediately after the Thanksgiving break. Obviously, this content will be available before the Thanksgiving so that you guys also have time to prepare for that. We have week 16, of course, Thanksgiving break, and then we have week 16, which has the actual exam 3 that is, which covers topics from chapters actually 9, 10, 11, and 12. So there are 9, 10, 11, and 12. That's 4 chapters. I think initially we were planning for 5 chapters, but we reduced it a little bit better to a lower number to have the content manageable. Otherwise, we'd have a lot of content to cover. Chapter 13 is going to be left for exam 4. And again, week 16 has actually 2 light chapters, extremely light as a matter of fact. One of them deals with the introduction to chemistry and the difference between a chemical change and a physical change, mainly, and naming conventions also of chemical compounds. And the second one deals a little bit more with the conditions of a chemical reactions, what needs to happen for a chemical reaction to happen, the types, the 2 main types when it comes to energy of chemical reaction, namely endothermic and exothermic reaction, and the role of entropy in a chemical reaction. And before that, of course, how chemical reactions by conservation of mass need to be balanced. So that's basically the topics of this units. You have a review that is due December 5th, because we have exam 4 on December 6th, which is a Monday before the finals week. The finals week actually starts from the 7th. We're not going to have an exam on the 7th. We're not going to have our final on the 7th. The final is due on Thursday, December 9th. It is going to be available on December 8th, though. The final is comprehensive. The final plus the other 4 exams add up to a section of your grade, which is called exams. And that is basically how you are assessed for this class. Let me get into, I already talked about the objectives. And if you go in here for week 16, you see basically the remaining assignments that are due. I mean, there is a point in here. Let me go back to talk about this assignment. This is not graded. Typically, we have our discussions graded for participation. This one is actually left out there for you guys to watch the recordings. Among other recordings is this one. If you have comments, if you have questions, please do ask them there. I don't get around immediately to answer your question or your discussion item. You may have other peers, which is actually beneficial to intervene and help around. So it's a good thing to have in here. As I was saying, this is not a graded assignment. Typically, we have discussions that are graded. After that, of course, you have exam 3 and the 2 topics I was talking about. Let me move back because I don't want, because if I go next, I'm going to hit the exam. And this exam is going to be available on November 30th, which is the Tuesday immediately after Thanksgiving. Don't forget that you have a review, which is also graded for participation, where you will get full credit if you do it. So this has been a practice, and I guess by now you know what's going on with the reviews. And that helps you also prepare for the actual exam. The content is here. I'm going to touch upon on it a little bit. And then the two PowerPoints for you guys to help you go through. Do not rely on my discussion or on these two PowerPoints. You still have to go through the content in the book. The final review for the exam 4, and then the exam 4. You may notice that there is no review for the final. The review for the final are all of the previous 4 reviews because it's comprehensive. Review for exam 1, review for exam 2, review for exam 3, review for exam 4. They are all preparation for the final because it's comprehensive. Let me go into the content for week 16 to see how that looks like. There are some definitions in here and the role of chemistry and the fact that the atoms is an old notion that was revived toward the end of the 19th century. And then basically we got a good grip over in the beginning of the 20th century, and atoms are extremely small. As a matter of fact, it takes about 10 to the power 23 of them for a few grams of a given material. And the difference between a physical property and a physical change and a chemical change, a physical change does not change the nature of the material. For example, you have hydrogen, you end up with hydrogen. You may have a different form of hydrogen, or water, for example, H2O. You may have it in a solid form, or a liquid form, or gas form, namely vapor. Those still H2O. However, in a chemical reaction, you may end up separating hydrogen and oxygen. You may have 2 elements that are gases, which is hydrogen, which is a gas, oxygen, which is a gas. And when they combine to give you water, water is actually a liquid at room temperature, which is a completely different properties than the other 2. That is in a nutshell what the difference between the 2. Chemistry is a branch of applied physics because a lot of the concepts come from there. And both of them, in addition to other branches of science like geology and astronomy, they constitute what is known as physical sciences. Here is an explanation of what I was talking about. And then every compound has a formula associated with it, whether it's a single element compound like oxygen, normal oxygen, or ozone, which is a different kind of oxygen. But in this case, you have a different combination of oxygen and so on and so forth. You can combine different elements like, for example, NaCl, which is sodium chloride, or in this case, ammonia, which has hydrogen and nitrogen in it, and so on and so forth. How do we name this compound? How do we have names for them? Well, there are 3 guidelines. The first one is to start from the left in the periodic table and move to the right, and you add the suffix or the suffix IDE. For example, in the case of sodium chloride, you start with sodium first because it's the one on the left in the periodic table, and then you move to the chlorine. You remove INE and replace it by IDE, and it becomes sodium chloride. That's rule number 1. Rule number 2, because in the case of, here is an example, for example, O2 and O3 elements, they can combine with different ratios to make different compounds. They're completely different. So how do we handle that? We add the prefixes, depending on how many we have. If we have 1, we say mono. If we have 2, we say di. If we have 3, tri, and then 4, tetra, and so on and so forth. For example, you have carbon, that is to the left. And how many oxygens do I have? I have 1. To make a distinction, between it and there is another combination of carbon and oxygen, we call this one carbon monoxide. The other one that has two oxygen atoms to form the molecule of CO2, we call it carbon dioxide. Okay, and you have the IDE also here. Don't forget that. Here's the second, the one to the right. The third guideline, the third rule in here when it comes to naming compounds is to use common names. Okay, we can call this one dihydrogen oxide or water. Okay, so in this case, it's known by its name, water. Because there is another one, actually, another combination of hydrogen and oxygen, and that is dihydrogen dioxide, or H2O2, and that is known as hydrogen peroxide. That's how it's known also, at least when you go to the when you buy it from the store. So this is the naming conventions. Chemical reactions, you have a chemical reaction usually is represented by this arrow that indicates the direction of the chemical reaction. On the one side, you have the reactants. On the other side, you have the products. Chemical reaction need to be balanced for the fact that mass is conserved. And the number of atoms in here for a single, basically, molecules to be formed of each or combined to form has to be balanced. That is stemming from the conservation of mass. There are all kinds of techniques to balance an equation. There are the pure algebraic methods, and there is the, you start from the right and counting each. You start from the left and counting each element separately until you balance the equation back and forth until you do it. But it's really a way of saying that mass is not changed, okay? The mass, how do we calculate it? We use typically, when we look at the periodic table, it gives me the mass, it gives me the weighted mass depending on the number of isotopes. And that number needs to be really read into grams, not kilograms. The SI unit for mass is kilogram, but the periodic table, they list the mass in grams. So if hydrogen, for example, or for helium, for example, it says it's 4, but I have 2 moles of it, okay? Oh, this is hydrogen, I'm sorry, this is hydrogen, not helium, what am I talking about? Hydrogen is about 1 gram, but they have 2 of them to form the hydrogen molecule, okay? Times 2, that's 4 grams. For oxygen, it's 16 on the periodic table, 15.999 to be more specific. When you multiply that by 2, you get 32 grams, and so on and so forth. For water, it's going to add up to, again, I have 2 times 1, which is 2, plus 16, that's 18, times 2, that's 36. If I add up 4 to 32, that is 36. That's what the balancing the equation. If I did not have a 2 in here, I have a problem. I will just have 2 grams in here plus 32, that's 34 grams. How do I end up with 36 grams? That's where the problem is. So in order to fix that, we have to balance the equation and place the 2 here. There is a number that you see repeated over and over and over, and that is Avogadro's number. And that tells me how many atoms or molecules do I have per mole of that substance, okay? That's exactly what the periodic table is. It gives you the mass of a mole of that element in grams. So the mass of a mole in grams of that element is listed on the periodic table. What is a mole? Is this number, 6.022 times 10 to the power 23. That's what a mole of that element, whatever that is. Chemical reaction can be impacted by different factors. One of them, the concentration, the temperature, and catalysts. Okay. The more stuff you have, the easier for the chemical reaction to proceed. The more reactants you have, the easier it is. The higher the temperature, the faster they are moving, the closer they can get from each other and they react. Catalysts also, they can bridge the gap of that energy because there is a gap in here that needs to be overcome, and that they help that. So that's basically what the role of a catalyst is. A chemical reaction can be exothermic. That means it gives energy, produces energy, like what happens, for example, when you burn fuel in the car. You produce energy, and that energy is transformed into a mechanical energy for the car to move. An endothermic chemical reaction is a chemical reaction that actually requires energy for it to happen. Okay, so this is this is another example of chemical reactions. Anytime a chemical reaction basically does not produce energy but requires it is called an endothermic chemical reaction. In order to do the calculations for energy, there is this table in here that is very helpful for the typical kinds of bonds that you see there. HH single bind all the way to a triple bind of nitrogen and nitrogen, and you have the energies in here associated with it. The energy is measured in kilojoules per mole. Remember, the number of moles is the number that is appended before the molecule in the equation. Again, the entropy plays a role in it. Remember from our thermodynamics unit chapter that the entropy tells us the direction with which it's always increasing. That's one thing. And for a chemical reaction to happen on its own without help, the entropy better increase. So that is an indication that this chemical reaction can proceed by itself. If it does not, if somehow the entropy is not increasing, it needs some sort of a catalyst. It needs some sort of something to help it in its sense that to leave the entropy of the universe higher than what you started with. That is a law that governs whether it's a chemical reaction for chemistry or a biology, whatever it is, it's governed by the entropy. Okay, so when you do the entropy before, when you do the entropy after, and if the entropy after is higher than the entropy before, then you're in good shape. It doesn't mean that this chemical reaction is valid chemical reaction, but in terms of entropy, at least you're good. That means you're not violating the entropy. But if somehow you measure the entropy of the products, you find it lower than the entropy of the reactants, you know that this chemical reaction is not possible because it would leave the universe with a less entropy than when you started with. That is not possible. That is impossible. So the entropy calculations in chemistry are very, very important, and they will tell you whether or not this chemical reaction is feasible or not realistic. It's impossible. So that is the connection for this. So this is the content for this chapter. It's brief introduction to chemistry, not this chapter, there's two of them. And I'm hoping that you do the reading and do the reviews and prepare your exams. If you have any questions, do not hesitate to send me a message via Canvas or through the discussion items, and do it as soon as possible. Don't wait until the end and then start asking questions. Thank you.